Welcome back. In Lesson 1 we said telemetry quality is the foundation of AIOps. This lesson is about building that foundation properly. We'll move beyond simple threshold monitoring into true observability, cover the 3 pillars of telemetry, route everything into a log analytics workspace, and define the SLIs and SLOs that make AI decisions meaningful. Let's get the distinction clear. Monitoring answers questions you already knew to ask. Is CPU above 90%? Did the agent check in? Observability is broader. It means collecting telemetry rich enough that you can ask new questions after an incident, including ones you never anticipated. That matters for AIOps because AI correlation is exactly the act of asking novel questions of your data. Without observability, the model has nothing interesting to work with. Observability rests on 3 pillars. Logs are discrete events, like a Windows update failure with an error code. Metrics are numeric time series, like boot time, percentage of devices healthy, or app crash rate. Traces follow the path of an operation across components. On endpoints, logs and metrics dominate, but traces show up when you follow something like enrollment through policy application to app install, end-to-end. The correlation engine for this module is a log analytics workspace. You route device and security telemetry into it, then prove it actually arrived before you trust any AI built on top. This little query counts distinct devices reporting in the last hour. If that number is far below your fleet size, fix ingestion first. An AI summary built on half your fleet is worse than no summary, because it still looks authoritative. To make fleet health an objective question, define indicators and targets. An SLI, a service level indicator, is a measured quantity, like the percentage of devices healthy. An SLO, a service level objective, is the target for it, say 98% over 24 hours. The gap to 100% is your error budget. If your healthy percentage drops to 96, you're burning that budget, and that's a concrete, trackable trigger for action. Because AIOps reasons over your alert stream, noise is poison. Alert on symptoms users actually feel, and on error budget burn, not on every transient blip. Each alert should be actionable, deduplicated, and carry enough context for both a human and an AI to triage it. Tune aggressively. Fewer, higher signal alerts produce better correlation and stop your team learning to ignore the pager. Here's the guardrail for this lesson. When an AI summarizes telemetry for a wide audience, apply least privilege at the data layer. Scope the underlying queries to exclude usernames, serial numbers, or security incident detail unless the viewer is entitled to them. A broadly shared AI summary must never leak data the reader could not have queried themselves. You enforce this at the query, not after the fact. Step back and see how it connects. Clean telemetry, plus clear SLOs, give your AI meaningful things to decide about. The 3 pillars feed the correlation we'll do in later lessons. Validated ingestion underpins every recommendation the model will ever make. And in the very next lesson we get hands-on with the language that ties it all together, KQL. Let's recap. Observability lets you ask new questions of rich telemetry, where monitoring only answers ones you anticipated. The 3 pillars are logs, metrics, and traces. And you make fleet health objective by defining SLIs, SLOs, and error budgets. Your task, in your log analytics workspace, run the ingestion sanity check against your real fleet size. Define one SLI and one SLO for endpoint health, write the KQL for the SLI, and state the error budget. Then pick one noisy alert and describe how you'd tune it. See you in Lesson 3.